Alright, moving ahead, we go to the next concept called as acceleration. Since childhood, you might have heard of this word, especially boys. कार का acceleration ज़बरदस्त है. In the context of vehicles attaining a certain amount of speed or velocity fast. How do we define it mathematically or physically? Acceleration is defined as the rate, listen to me carefully, the rate of change of velocity per unit time. The rate of change of velocity per unit time. Acceleration is denoted by a symbol small a. It is given by the rate of change of velocity per unit time. V, which is the final velocity. In average velocity, we define average velocity as initial velocity plus final velocity upon 2, wherein the initial velocity was denoted by symbol u, final velocity was denoted by symbol v. So acceleration is defined as a rate of change of velocity per unit time. So final velocity minus initial velocity per unit time. That is the definition of acceleration. Here, a is the acceleration, v is the final velocity, u is the initial velocity, t is the time. What is the unit of acceleration? It is meter per second square. How do I know it is necessarily meter per second square? Here, both are velocities. So the numerator ka unit will be meter per second. The denominator ka unit will be time, so will be second. I can consider this to be second upon 1. So here by division, a by b divided by c by d becomes into d by c. So acceleration ka unit is meter per second square or meter second inverse. Acceleration, guys, is of two types. One, uniform acceleration or positive acceleration. Non-uniform acceleration or negative acceleration. This negative acceleration can also be called as deceleration. So, like the definition is a bit in the zone of uniform motion and non-uniform motion. What did we define uniform motion and non-uniform motion a little while ago? Uniform motion was a type of motion in which equal distances were covered in equal intervals of time. Non-uniform motion were unequal distances covered in equal intervals of time. For uniform acceleration, it is equal velocities covered in equal intervals of time, or equal velocities attained in equal intervals of time. Non-uniform acceleration is unequal velocities attained in equal intervals of time. You can easily differentiate between positive and negative acceleration in the sense when a car is stationary and starts with a zoom and on the highway attains a constant speed of say 100 or 150 kilometers per hour, that zone is then the car is said to be uniform acceleration. Deceleration and negative acceleration, you can imagine it the other way around. When the car is already at 150 km per hour, because of an incoming fast vehicle on the opposite side, it suddenly you have to put on the emergency brake or reduce the speed so as to bypass that vehicle or stop the vehicle with a jerk. That is sudden change is wherein the vehicle suddenly stops is deceleration or negative acceleration. So A is defined as V minus U by T, rate of change of velocity per unit time. A little thing which is not of much use right now but will be very useful to us a little while later. If you rearrange this definition, if you cross multiply, what becomes? AT is equal to V minus U. If you take the negative U on the right hand side or the left hand side, you get AT plus U is equal to V. If you rearrange the terms, guys, you get V is equal to U plus AT. That is what we call as the first equation of motion. Although not relevant right now, note this because it will help you understand what we do in the later part of this chapter. So for now the info is enough. Acceleration is the rate of change of velocity per unit time. V is the final velocity, U is the initial velocity, T is the time. Unit is meter per second square. Let's see two simple examples actually and try and make sense of this acceleration concept. A train starts from a station and attains uniform acceleration with speed of 40 kilometers per hour in 10 minutes. Find acceleration. A train has started from a station. So in other words, the train was initially stationary at the station. So it started. So its initial velocity when it was stationary was 0 meters per second. After a particular amount of time, after it started traveling, it attained a fixed or a constant speed or velocity of 40 kilometers per hour. So the final velocity was 40 kilometer per hour. I know for a fact that I need to convert whatever is there in kilometer per hour in meter per second because my SI unit of speed is meter per second. As per what I studied, I simply multiply kilometer per hour or simply multiply the velocity with 5 by 18 to convert it to meters per second. So my V is 200 by 18 meters per second. My U is 0 meters per second. My T, my time is 10 minutes. 1 minute is 60 seconds, so 10 minutes will be 10 into 60. My time is 600 seconds. I now guys have my V, have my U, have my T. So in the original equation, I have all knowns now. Can I substitute it in my definition of acceleration? A is equal to V minus U by T. I absolutely can. Let's see what happens. A is equal to V minus U by T. A is equal to 200 by 18 minus 0 upon 600. A is equal to 200 by 18 divided by 600 by, let's say, 1. This is A by B divided by C by D. A by B divided by C by D is always A by B into D by C. So A is 200 by 80 into 1 by 600. 2 zeros go off, 2 zeros go off. I can say 2 ones are 2 threes are. So my acceleration, guys, is 1 upon 54 meters per second square. Final velocity was 200 by 18. Initial velocity was 0. The time was 600 seconds. Obviously, I was given it in 10 minutes. I was given this in 40 kilometers per hour. Upon substitution, I am getting my acceleration as 1 upon 54 meter per second square. Let's see another simple example. Bus decreases speed from 80 kilometers per hour to 60 kilometers per hour in 5 seconds. Find acceleration of the bus. Here there is no information of the bus being at rest, the bus having 0 velocity. So my initial, it is already in motion and the initial velocity is said to be 80 kilometers per hour, while the final velocity is said to be, and this reduction in the already moving bus from 80 to 60 happens in a time period of 5 seconds. So we have to find the acceleration. Needless to say, the kilometer per hour needs to be converted to meters per second. So U becomes 80 into 5 by 18 meters per second. V becomes 60 into 5 by 18 meters per second. U becomes 400 by 18 meters per second. V becomes 300 by 18 meters per second. My time, guys, is 5 seconds. Can I substitute it in the original equation? Yes, I can. Let's do it. A is equal to V minus U by T. My V is 400 by 80. Or rather, my V or final velocity is 300 by 80. My final velocity is 400 by 80, while my time t is 5 seconds. So what do I get, guys? I get, and just for lack of space, do the remaining sum here. Here I am getting acceleration is equal to 300 by 18 minus 400 by 18 is negative 100 by 18, the whole upon 5 by 1. So as per A by B divided by C by D, I can say acceleration works out to be minus 1 by 1.11 meter per second square. Acceleration, as you can see, is negative. This is an example of negative acceleration or deceleration, wherein an object from high speed comes to lesser speed or zero. Positive acceleration is a stationary object attaining a particular speed. And because acceleration is defined as the rate of change of velocity per unit time, and velocity itself is a vector, that makes acceleration a vector. And a vector, by definition, can be positive, can be negative, can be zero.